Uh, Hello, everybody. My name is Dimitar. I'm a principal data engineer at Booking.com and one of the architects, and I usually say fortunately or unfortunately, over analytical cloud data platform. That's because colleagues both hate it and love it. Is the baggage that comes with the job. Um, so there is a marketing preamble that the organization usually wants me to do, when I speak. So there is that. I'll try to be brief. Uh, who knows Booking.com or is a customer of Booking.com? All right. So a very brief introduction as to the marketing language. We are the premier travel retailer, and the goal is to actually allow people to experience the world as they want. So what does it actually mean in terms of data? Well, it's a lot as far as we're concerned. We have over 2,000 data practitioners using our cloud data platform right now. So this is across varying roles, data engineers, machine learning engineers. As of recently, we have analytics engineers as well as a new flavor within our craft. Uh, Folks that primarily focus on data modeling alone at this scale. We have approximately, as of this morning, uh, 203,000 tables within the organization. This is both what we call managed or published data, which is like in production and reuse, and work in progress, being in individual or group workspaces. It's organized in varying databases, schemas, and many methodologies for modeling. We haven't been able to converge on one because, in my opinion, large organizations are unable to converge on one, but we're going to talk about that as well. So we have many petabytes of data. The number is, let's say, double digit. It's a bit outdated. Let's say it's triple digits petabytes of data. The organization is a bit uneasy about sharing the exact number. So if you get me a beer, I'll probably tell you, but not on the record. We have a few multi-petabyte size tables that people get to query frequently, and we have a total of 1.76 quadrillion records across everything that the system could count last night or so. Now, it also gets heavily queried. We have just analytical queries is around 168,000. Um, to give you a scale, the number of daily updates we do, refreshes we manually do, and not everything is manually refreshed of Iceberg tables, is about 20,000. So like the cadence in which data arrives is actually quite fast as well. And there is also a number of grand scenario operations that grows into millions per week. Um, this is, if you wish, what we had to handle and what the new platform handles. I'll give you a bit of a history lesson. Our older platform was on Hadoop 2, very much aged. It was on-prem. We've been told it's very big. Someone was quoted as one of the biggest deployments in Europe of Hadoop 2. It was in very high triple-digit petabytes in each cluster, and we had two of them for redundancy. And as we started migrating, we found out that they're not identical. So we technically had a very large amount of data that was organized in an organic fashion that we call the data swamp trademark. Now, we have largely moved away from that. It's now more close to a well-managed pond, and we're building ice lake houses and stuff. But yeah, that's where we started from. Um, so the architecture of the new platform we built is the focus will start with Iceberg by default. So this is one of the choices we made. That is cloud native, AWS first, Snowflake heavily in the mix, Iceberg by default. And I'm saying by default rather than the only format because we try to push for that at some point, and that's not a good idea. You end up jamming yourself more than actually enabling your organization. And we also found there is inherent advantages in using, for example, as with Snowflake native tables rather than Iceberg alone. That difference is disappearing, but still there. The other part is everything's Parquet as far as we're concerned. Some data does arrive, in a different format, potentially Avro or whatever else, but gets written as Parquet files, and it's stored, except for the Snowflake native tables, in our own S3 buckets. So plural, because we're afraid that we might hit a limit on AWS for how many handles you can have concurrently on a bucket. As in, yeah, we were unsure if that is true anymore, but nonetheless, We took some precautions because we're paranoid. You might hear that a few times during the presentation. We are very paranoid. Now we have two catalogs, and I'm not calling either of them primary. They're, somewhat interleaved, and that is AWS Glue and Snowflake. And they manage different parts of the deployment. I'll show you in a moment what that looks like. And we have multiple compute engines. Our team has begun to rebrand that as Bring Your Own Compute, but I'm just calling it, we have different teams with different needs. It is impossible to converge to a single engine or even a single client, how your data is going to be queried. You can try that. If your organization is small or, very well structured, great. At like our size, it's impossible, and you create more problems than you actually solve. The other one is federated catalog. You're going to see a lot of things that Victor mentioned during his presentation. We're actually doing that in practice. It is real examples of things we're doing at the moment, not future work or anything else. So like there's going to be a lot of echoes, I would say. And the focus in this federated catalog integrations that we have is what we're calling zero ETL. So there is different names. The team calls it bring your own storage. I think it's a misnomer, but they like, fancy things. I call it zero ETL. That is, keep data as is, don't move it, query it when you need to query it, and keep it where it is, especially if it's in petabyte scale. Just don't move it across regions, clouds, buckets, whatever be it. And access control wise, so we're gonna go into a bit more details there. If with some engines, if your data is not sensitive, there is no sensitive columns or rows in it, you get a direct handle to the prefix on S3, and then your engine picks it up. We trust that. If you have to do any sort of fine-grained access control, and we do this a lot, so more than 60% of our tables have some form of fine-grained access control, be it column mask or multiple column masks or multiple different column masks or a low-level policy. For those, we actually exclusively run the compute via Snowflake, and we have Immuta as an engine that actually applies the rules. It is, how fancy can I call it? It is an object/user attribute-based access control. So it was not enough to do it on objects. We also need user attributes to be able to manage access. That's because otherwise we estimate that we're going to create several tens of thousands of policies just to be able to do it if we use RBAC. So it's got to be actually a rule-based system in the end. In the end, this get applied into Snowflake so that they work. There is almost no, well, there is minimal, computational cost that you pay. It's mostly the rule engine that applies them. All right, so what does this look like? Sort of like this, you have all the systems within the organization, front end, back end, operational databases, data stream, pipelines, everything in between, and the data that is interesting for us in analytical sense ends up on the analytical data platform. Oh, by the way, its name is BDX. We start everything that we create with B. So of course it's the booking.com data exchange, and it's X as an exchange because it sounds cool. Like, yes. And there's the exchange part you can actually see in a bit. So we have stream ingestion. Stream ingestion pipes get macro batched right now for a few reasons. So we actually write data to S3 only every hour or so. Everything else is like batch ingestion. So these are a couple of thousand pipelines. Everything that we ingest lands on Iceberg on S3 with some exceptions. So you're going to hear with some exceptions throughout the presentation. Everything has an exception. Ask me why, if you're interested. So this is, if you wish, our raw data lake, as we call it. Data has arrived from whatever source system. Immediately, fine-grained or access control rules apply in any sort of shape or form before anybody process the system can access it. Then we have the more managed space within the system that is primarily in Snowflake. So Snowflake has the superset of data within the organization. That is everything that's on S3 in Iceberg, other catalogs that we have federated or connected, through a federation, or like anything derived as a Snowflake native table is available with the Snowflake catalog. Control plane, I like the terminology. And we have workspaces, so these are dev or non-production databases, and we also have production or published databases, as we call them. So these are abstractions where your actual data that other people get to use that are outside of your team get to read. And we have one rule: people don't write data, machines write data. So any published data can't be written by a human. It should only be written by a managed process, by a workflow, in effect. And then we have the different evolutions of structured data. Like, and when I talk about data warehousing, I mean more well modernized, but traditional enterprise data warehousing. So data vault. Anybody familiar with data vault methodology? Okay, wrong crowd. Interesting. What about dimensional modeling? Anybody? Okay, all right. So we get to do that as well. But we're trying not to shove it down people's throats. If you have done that, look it up. Kimball data modeling, cool, very heavyweight, not really big data thing, but if you actually want structure, it's the thing. And on top of that, we're now creating semantic views or semantic models. The idea is that we capture the entity relationship between different tables so we can standardize them, that we can have them in a metrics catalog and create common metrics. And the way that we have connected this on the slide, you only see the BI tools, but technically you get to use them in more than one tool. So either ThoughtSpot, Tableau, or this also goes into the AI system. I have a slide about AI. If we don't have time, we're going to skip it. Otherwise, ask me about it. We're very proud of it because we actually think it makes sense and it's non-hype AI at this point. I helped build it, so I claim so. And I have a degree in AI. Now, multiple compute engines underneath. The the split is somewhere around 60% for Spark, 40% for DBT at this point. And it's most of an artifact of the past. We on Hadoop have a mix of HiveQL queries and Spark queries. HiveQL was not very scalable. When we migrated to a new platform, we asked people to do whatever they had verbatim and translate it into DBT. That worked well. Spark remained a Spark. We also have very heavy-duty Spark jobs for machine learning, anything else, actually proper statistical analysis, things like that, but not many, almost 20% of them. There is also Snowpark in the mix, as of recently Snowpark Connect as well. So this is more readily used. We were in the early trials, so there's more workloads that we're testing this, and it's all ran on Kubernetes. But of course, it's our flavor of Kubernetes. It's called the Booking Kubernetes Service. So it's BKS, and then it runs on top of Astronomer's Airflow. All right. Now, when we talk about catalog federation, so I'm going to give you an example of like an inbound catalog federation. This is very much to what Victor said. It's about compliance, or it's about isolation. In this particular example, we had our colleagues from FinTech. For various reasons, they need to operate either in a different region, the data is pinned there, or they really need isolation where nobody else should touch that. So what they have is their output that is meant for analytical consumption gets written in their own data lake on S3. Parquet, Iceberg, Glue is the main catalog. We Terraform one-off integration between the catalogs, so the Iceberg REST catalog on Glue that Glue exposes, with Snowflake's catalog integration, and the storage volume in Snowflake to the S3 bucket. There is nowadays possibility to use vended credentials. We don't do that. If you ask me why, it has something to do with private link and the way that S3 gateways work there, but more on that later or afterwards. And the table that is actually any table that appears in our colleagues' catalog, external catalog, is materialized almost right away in Snowflake, and from there we apply all the fine-grained access control we need because this is usually well-restricted data. However, what it means is the data stays where it is unless someone queries it, and when people query, they usually don't do a full scan. They get the most recent inserted data, and they can restrict that with time travel. So it's generally like smaller chunks. So we don't move large volume. We try not to move large volumes of data between the different systems. Now, we also do this in the opposite direction. In this case, the primary setup is with Snowflake shares. So we have either Iceberg or Snowflake native tables. We have the colleagues from finance. That's different from fintech. Common mistake within the organization. The finance team within our organization is the folks that deal with regulators. They want absolutely isolated environment as well. So nobody can touch that. There is a ton of requirements. Anybody listed on the US stock exchange? So have you heard of SOX? Yeah, so that is the SOXified environment, right? Like it ain't fun, and it also is not fun if you actually do something bad there. Um, like if you're wondering why the Sarbanes-Oxley Act exists, you should look up Enron. So that's where it all comes from. So failure, moving to success. What we actually do is any data produced within our environment, within the analytical environment, coming from any other source, gets processed. We create secure views before we share the data. And because the secure views are agnostic of where data is coming from, it can be either a Snowflake native or an Iceberg table. It really doesn't matter. The reason why we create secure views is this is, if you wish, our clearinghouse. This is the gateway. Before data moves out, especially sensitive data, we want to make sure that certain conditions are met. Be it filtering rows, desensitizing columns, and so forth. That's because the other instance might have different access control rules. We actually don't manage the other instance's access control rules. It's a completely different team that manages that. We just give them the common tools, but we decide at the gateway before sending data over what is acceptable. Now, and here is why it's the exchange. So it actually sits in the middle, aside from containing maybe 80% of the analytical data of the organization, maybe a bit more. It does get data in from all source systems, including other federated catalogs, and sends data out the same way as well. We also have almost circular dependencies. So we do have use cases where our colleagues from finance now produce data and share it back in the same manner. So if they have a consumer downstream from them within the central, the common analytical data platform, then they share it, and that's easily consumable by everybody. Now we're gonna go into a fun topic, which is something very hot for us right now, and I'm gonna call it catalog primacy. So at some point, we effectively need to decide, or we are right now deciding, if you wish, which is going to be our primary Iceberg catalog. We currently have two. We have Snowflake in the middle. Snowflake has Snowflake managed tables, Snowflake native tables. They're within Snowflake's AWS account. We also have Snowflake managed Iceberg tables, which are in a separate AWS account in buckets. These are primarily used in development, personal workspaces, the non-production workloads. Then we have the production workloads, and those are in a separate AWS account with a separate set of buckets where Glue is the primary catalog. And we use the catalog federation to talk to the catalog. So this is over the Glue Iceberg REST interface. And how do different engines, let's say the two big ones, get to query it? Well, for Spark, if you need table level access or the table is not sensitive, then you get vendor credentials on S3. You pull the data metadata from Glue, and you get S3 prefix creds. Now, if there is any fine-grained access, then you gotta go through Snowflake. Our system that issues you credentials is just gonna say, that doesn't work. It's gonna give you a handle, and then we have like a wrapper that we have written ourselves. We call it the BDX SDK. And then the BDX SDK is going to take care that you get the right credentials, gives you high-level functions to use within your Spark job, so you don't have to think about it. Now, the advantage of having the BDX SDK is that we can actually swap things without having to tell colleagues. Now, we do tell them, but it means that migrations, after the pain of creating the SDK, migrations might be easier going forward, at least within the same stack, like same end-user stack at least. Now, for dbt, actually, dbt sees everything as a table because dbt runs in Snowflake primarily, and it doesn't matter where the data actually resides, as long as it's a table Snowflake can index, which is pretty much everything within our environment, so that's fairly easy. The alternative deployment we've been thinking about, and I'm taking suggestions here, looks like this. So this would be, Snowflake would be the primary catalog. We don't necessarily use Glue as much in this setup. We still run everything on AWS S3. We potentially deprecate over time the Snowflake native tables, and I'll tell you why that will be possible with this setup. And we still have two sets of buckets for managed or published space and unmanaged or development work in progress space, but the process would look slightly different. For table level, same. For fine-grained access control, you still go to Snowflake, but now we can potentially also use Snowpark Connect. We have many jobs that need to query both Snowflake and data on S3. These don't necessarily perform well. At least I call them hybrid. Um, and the idea is that we can offload this to Snowflake to run actually with better performance, since Snowflake is, in my opinion, a cheat-oriented database, as in it tries to do as little as possible data processing. So like we talked earlier about, metadata-only operations like min, max, and counts. Snowflake tends to do that well. However, if you're running this in Spark and the predicate pushdown doesn't trigger, it turns into a full scan over a very large petabyte-sized data structure. So we want the engine that has the best ability to cheat with the provided metadata to be able to run most of the heavy-duty compute. Now, what about dbt? The same, literally no change. We just might need to update our macros. And of course, we've created our own. Who's familiar with dbt? Okay, so yeah, we started with off-the-shelf macros, and now we have our own, because similar to how we had to create our own Spark client, we had to write our own customization because we thought we were special, or we were definitely special. All right, now, so I'm gonna skip the AI slide, but the idea generally is, since everything is a table, we can address everything. And what we've started doing is capturing entity relationships, creating metrics in the metrics catalog, and having effectively one engine to query them all and give the data to us to scale. What has happened in the meantime is that effectively the world of semantic layers for BI and semantic layers for AI converged. So you need about the same information, about the same metadata to use both, which is why we're very happy about that. That means that I built my metrics, I have my definition, I can now have a structured way to feed this to my BI tools downstream, and I move calculated fields off BI into a more manageable layer, well standardized, and I can expose the same to text to SQL or even like agentic flows nowadays, which is what we're testing at the moment. And looking forward to standards that some of our vendors, including Snowflake, are part of. So we've actually talked to half of the people on that list, but it doesn't matter. But yes, this is what we're looking for. All right, going forward, me are not entirely happy with the adoption of some of the niceties that Iceberg gives us. Many workflows that we still have rely on partitions, like as in, I don't know, time-based partitions at time of writing. Who else does that? All right. Okay. Yeah. So we've been discussing that the better way is that you partition or cluster your data based on read pattern, and you actually use time travel to determine what is your delta. So we have started using time travel for mini CDC between jobs. That seems to work well, but is not at scale. So we tend to expand that. Next one is branching. So we have many critical workloads. And what we do right now is we've created our own blue-green deployment sort of process. So we clone the tables that we need to write in Snowflake, or clone the entire schema. We write into the clone. We run very heavy-duty validation. And if it's all fine, we do like an atomic swap of the new and the old copy. Problems with that? At certain scale, even Snowflake clones take a while, especially because if you have a lot of metadata to write. Second, the history in terms of time travel of the table starts at the time you cloned it. So you effectively lost history. You can do a three-way swap, which we have tried. And then whenever you need to fail an operation, then you lose your history again. So branching works nicely. Effectively, the intention is for high criticality process, we write on a branch, we validate everything on the branch. And once we're done, we just fast forward and, single transaction, nobody saw anything, and everything is fail safe as far as we can see it. The other part is thinking more longer term, migrating Snowflake native tables to Iceberg. Until now, that was not always a possibility. One, we didn't want to limit ourselves. Two, within data warehousing, where we have heavy joins and many other heavy processes, Snowflake native tables still perform better. The major difference is how you write your Iceberg files. So how you write your Parquet files, how you write everything in Iceberg. So file size matters. The stats that you write within your files matter a lot. So if we use Snowflake's managed Iceberg, the difference is quite small. It has shrunk sufficiently that we can generally, disregard any difference in performance, and it's getting better over time. However, otherwise, we need to have every engine be trusted to do the right thing in terms of how they're going to write per K in Iceberg, so that we have consistent output and performance on both reads and writes. Some consideration there. Snowpark Connect we mentioned. Who has tried Snowpark Connect? Oh, okay. You should try. It's public, right? I'm not. Okay. Sorry, because we were early testers. I just don't want to leak anything. All right. And stream ingestion, I mentioned we are doing macro batching right now. That's going away next year. Streamlit. Who has tried Streamlit, either standalone or in Snowflake? So we didn't think it's going to be a hit. Now, we told to our colleagues, do you want to try Streamlit? You can query your Iceberg tables, no problem, right? In less than 2 months, as a pet project of a couple of colleagues, we have 20 Streamlit deployments right now. And we found out that half of them don't even query data. People just were thinking, where do they deploy their tiny Streamlit app? They were running this in Kubernetes, and it turned out that it's cheaper to actually run it in Snowflake because they have very little internal traffic. So we are now, designing to spin this up and manage it properly. I was not a fan, but it works and people are happy. So yeah, I'm going to put it as a victory in my annual review. So there you go. All right. Well, folks, thank you very much. Any questions? Oh, all right.
I'll just double check on that one.
Maybe just a question from my side.
Of course.
Is Hadoop off?
So Hadoop, we've decommissioned completely one of our cluster. Our second cluster is, I think, was about to be decommissioned to the 27th of October, but it's not in active use anymore. But this migration took, so I've been in the company for 4 years. It took 4 years. But we've been told it's one of the largest migration in the world. We're not trying to, benchmark or measure, but if your migration was bigger, tell us. We're actively trying to find out if it was. We were told it's among the top 5 in the world. As in we considered shipping containers of hard drives because we're afraid that, the bandwidth that AWS has might not be able to keep up.
All right, just reading this question from the chat. So from Gaurav, how is attribute-driven user access provisioning? How does attribute-driven user access provisioning work? How is your IDP handling that?
Great question. So I removed that slide, unfortunately. We have a couple of systems in the loop. So let's break it into authentication and authorization. On the authentication side, it's fairly straightforward. So for humans, it's Okta. And we are using pretty much every integration Okta has with Snowflake. So we use Kim for provisioning users in groups, and groups or rows in Snowflake we use for very coarse access. So this is administrative rights, things like that. And then we use Kim to also synchronize from Workday through Okta to Snowflake user and user attributes. And because if you wish, Workday and Okta are the source of truth when it comes to that, we try that implicitly. Now, for services, we have 2 or 3 levels of service access. If it's a privileged service, it has to use service OAuth, which is registered in Okta as well. If it is a workflow, so a service that has continuously spinning pods, we actually use Vault DB Engine. So there is a defined role, and just in time when your pod spins up, Vault is going to issue creds that assume a predefined role within Snowflake. And these get recycled quite often, the credentials, also the users. We actually had it configured in such a way, reading a blog post, that each new pod created a new user that assumed the same role. And that resulted in provisioning more than 70,000 users per day. And we were told by Snowflake that we're the world record breaker by another order of magnitude. So we stopped that. That's literally, we continuously invalidated all the IAM cache of our instances as a result, because we provisioned a user every 1.7 seconds or something like that. We had an estimate at some point. Now, for access control, so for authorization, we use Immuta. Immuta allows us to configure, so there is different access and different schemes you can use in Immuta, but effectively you have like subscription policies, so a person has access to a table or like a data source. Or you can specify further more specific policies that you can apply generically across multiple objects or all objects. That is, for example, objects that have tags like PAI or whatever is deemed sensitive, then certain masking policies apply. The default being you get no's, like that column is completely completely redacted. Or row level policies, and only users with specific attributes get full access or get a different level of access if necessary. Now, we don't proxy requests via Immuta. Instead, Immuta synchronizes the rules with Snowflake's native access control rules. So Snowflake's native table, column masking, or row level policies. So that means on the query side, we don't have to think about anything else. We just use it. If you have access, then it was meant that you have access. And both people's identities are in Immuta, and service identities are in Immuta. So services also go via Immuta in terms of access being granted to them. Hopefully that answers the question. If anybody's interested, we can provide even more details. We have a whole presentation on that. It's just that we didn't think it's going to be enough time.
Hi, Dimi. Gokula here. So overall, whatever you showed, it is great. I have one follow-up question. After seeing the architecture, it is completely on the multi-tenant architecture. So can you just talk about like how are you planning to support that multi-architecture with your primary catalog? What you are looking forward?
Well, we're highly certain that even with a single, like, let's say, there's two scenarios. Even if we make glue or retain glue as the primary catalog for Iceberg, for published Iceberg data, we would still need to have Snowflake in the mix until we have, I don't know, community standard for fine-grained access in Iceberg, or S3 tables, or maybe some changes there, or cloud, lake formation changes, or S3SG, like whatever the implementation might look like in the end, or we would eventually need to converge to a single solution. Because of our increasing data warehousing workloads, we don't think that Snowflake would ever be out of the mix. So there isn't any advantage of excluding that. If we switch to Snowflake being the primary catalog, the eliminated system from the design that you saw would be largely glue. Now, we would still have a process that would vend credentials to jobs if they need to read straight from S3, like any Spark job that we have. The alternative would be a potentially lightweight in terms of what our users need to do, but heavyweight in terms of shifting compute to start using more Snowpark Connect. That is, we have the instructions that Spark needs for the portable jobs to run in Snowflake, as Snowpark, rather than natively on a Spark cluster. What we found out and why we like it is, aside from the more consistent use of predicate pushdown when you use Snowpark, or actually very consistent usage, the other one is we limit the number of network I/O, since we don't have to have data being pulled out, put somewhere, then gets into Spark in memory and then written back. A few round trips are removed. We have an exact number that I've been asked not to share yet about how much of performance improvement is, but it's high double digits in percentage. And we're very happy about that. The other thing is that the whole execution process gets simplified, so we can run on much, much smaller Spark clusters. And from our experience, it's much easier, especially if we have many, experienced users with major Spark deployments, it's much easier to tighten our Snowflake workloads, like Snowflake warehouses, Snowflake compute, compared to Spark. We have different tools to help with that, but it is almost trivial, especially with the tools like Select, which we use for Select Dev for Snowflake cost and compute management, compared to potentially doing this on Spark, at the moment at least. Hope that helps.
Yeah, thank you.
Perfect. Then I would say thank you very much, Dimitar. So